Like you can pass G++ the .i file, the .s file, the .o file, and it will just pick right up. It's like, oh, you're here? Okay, let's do that part, and it does it for you. Oh, you're here? Okay, let's do this step and that step for you. Did you guys see that? So I actually never run LD directly except like, just to show you that LD exists. It's the linker, I never run it. I just run G++, and G++ like, oh, you need the linker step run, and it types in the right parameters and all that stuff. Why waste my brain power on that? Yeah, question.
I was just gonna say, the partial compiler, partial compilation, you can go in any step, right? Like you can go to, because that only brings you to .o, can it make you go to .s? Or
yeah. So to go to the, I'm gonna need to. CSCI 40, right? You have hello world, compile it, you run it, right? Stay. CSCI 45. So you have AS, the assembler, you have LD, the linker, you've got the preprocessor whose name eludes me because I never run it directly, because why would I? And this is the compiler, actually is this step right here. So the compiler is just one small step of this whole chain. G++, you can by passing it -E, -S, -C, you can choose to go this far and stop, right? And -S is a great help in this class. You know why? What are you guys going to be writing?
assembly code.
What does -S do?
It's the assembly code.
Yeah. Like if you can't remember how to do a for loop in assembly, write in C++, G++ -S. Oh, that's how you do it. It's the, you guys hear that? Like, this is the best tutor you will have in this class, because the compiler knows assembly very well, right? And so if you're like, all right, how do I do a function call again? Make a function call, -S. Oh, got it. Thank you. This knows assembly better than me, right? So the assembly you get out of this, by the way, is garbage. It's absolute hot garbage. But somewhere within there is the answer you're looking for. So yeah, this wouldn't be my first step. My first step would be to read the textbook. And so the textbook, by the way, is by a guy named Bruce Smith. And he's like this rugby guy from England. He writes about two things: Raspberry Pi, assembly programming kind of stuff, and like rugby. And do you want to pass off the camera? Anyone? You want to? Okay, thank you. The book that we're going to read for this semester is Smith. Look at that internet speed. All right, 4th edition. 404, not. That's good. Let's go to Amazon. Yeah, for a while I was worried the guy was dead because like his website just like stopped working. Okay, that's 3rd edition. 4th edition. Yeah, that guy looks like a rugby player. Might be football. Right. Bruce. Raspberry Pi. That, yeah, Kindle edition. Okay. is 4th edition. There it is. Okay. So that's your textbook. And you know that it's not a real textbook like for college because it's $20.
Yeah.
Isn't that weird? Like when something is marketed to college freshmen, the richest people in the world, it's like $200. I had a textbook that was 80 pages and it was $250. And I was like, it's $3 a page, dude. It was not worth that much money. So that is your textbook. Buy this book, 100% guaranteed. You will agree with me. This book is worth every penny. This book is really, really good. Why? Because it's not a textbook. It's written for people like you and me. It's basically like, oh, you've never done assembly programming before? Cool. Here's how you do it. And you're doing assembly programming on a Raspberry Pi? Cool. Perfect. Okay. And I had never done assembly programming in ARM before I taught this class. And I was debating doing it the way that I learned it. But I'm like, Pi's are cool. And ARM32 is a nice assembly language. So what I did was I bought this book. I went to Batter Up Pancakes, and I read the book. And after that, I was like, all right, I know assembly language. Like, it's that good. It's very easy read, very straightforward. It's cheap, very readable. He doesn't even expect you to know how to use Vim or any of that stuff. Like you can skip probably the first couple chapters because you know Vim already and stuff like that. And it just takes you through A through Z, and it's fantastic. Yeah.
Can you drop the link on Discord?
Yeah. It is in the lecture. All right. So, yeah. All right. So, do you guys kind of see what I'm getting at when I'm telling you like this class is the one in which we kind of pull the blankets out of the way? Like, this is what's actually going on. Because all this stuff actually kind of matters. Because like Aaron, who's not here today, he was having trouble compiling his code, and he wasn't getting a compilation error. He was getting a linker error, right? And when do you learn about linkers? In this class. Yeah.
I think it was his Doom project had that issue, wasn't it? So I helped him fix that because he had like a lot of segmentation faults in that.
Yeah. Yeah, and the problem was with this stuff, not with this stuff, which is what we're used to, right? We're used to having compilation. Yeah, linker. So this spot, and guess what? Guess what? If you ask experienced computer science professionals whether they'd rather have a compiler error or a linker error, let me tell you which one we prefer. We prefer compiler errors. By far. By far. Why? Because, for one thing, linker errors are not designed to be really human readable. Like, when you get a linker error, it looks like somebody walked on your keyboard, and you have to be like, what? And part B, they can be really, really annoying to diagnose and fix. So, again, that's why this class is so valuable. So, you guys want to see a linker error?
Yes.
All right.
Trust me, I see my picture of him.
You've seen enough for one lifetime? All right.
Visual Studio Code has a lot of link errors.
All right. So, yeah, anyone see what the, is there a compiler error in this code?
You're forgetting an I.
What?
You're forgetting an I in there.
But is there a compiler error?
CSCI's not flagging it. There is no compiler error, but
There's no compiler. This is valid C++ code.
Yeah, but fine. There's a link error there.
And if you want to actually see why, like, function,
Yeah.
right?
We're just not running it.
Fine. There's nothing wrong with this code. This is perfectly valid C++. So let's try compiling it. Linker error. You guys see that? LD.
Doesn't make any sense.
LD stands for living death. No.
Fate worse than death.
So that's a linker error. And it's saying user lib GCC x86 64-bit GNU Linux version 10 up a directory. Thanks for doing that. x86 64 Linux GNU scrt1.o in function underscore start. What? I don't have a function called start. What are you talking about? There's no start function here. What's that? I got a function called man. What?
It
does, yeah.
I was just going to say that's all just to say, hey, we don't have a main.
Yeah.
Just having like a temper
LD is not
tantrum.
designed to be human readable, or not very, yeah.
So underneath that it says text plus 0 times 24. What is that for?
So this is hex, right?
Okay.
So this is memory address 32 plus 4, 36. So at memory address 36 in our code, there's an undefined reference to main. So that means our assembly code called a function called main, and it's calling it from a function called start. Where the hell is start? I didn't write start. Right? You guys see me write start? I didn't write start. How is start calling main? You know the answer, Sing?
Through the linker.
Through the linker? The, no. Start is from this file right here. Skirt.
Squirtle?
Skirtle. Skirtle. The C runtime library. Okay? So main is not the beginning of your program. What? It's not. It's not. It's not the end of your program either. We've been lying to you this entire time. All of your computer science professors, me included, tell you main is the beginning of, nope, it's not. Start is. This is the beginning of your program. And start calls main. And when main returns, it takes the return value of main and returns that to the operating system. A function called exit. So the C runtime library is actually the actual entry point of the program. And so it calls main, because that's what you do when it calls main. That's how the program begins. And it's saying, I can't find this main fellow that you're talking about. And so collect two, hell is collect two? Remember how I told you this is the GNU compiler collection, right? When you run G++, it tries to figure out, okay, we need to do the assembly step or the linker step, right? And so there's this thing under the hood that is kind of like navigating the process. You guys understand? And so the collection said the error returned 1 exit status. You guys understand that now? When you return a 1 as an error code, the compiler suite detects that and stops. It does not actually build an A.M. You guys with me now? So when you return 1, normally it's just ignored by the operating system. But when LD returns 1, the GNU compiler collection looks at it and goes, oh, linking failed, and it stops. You guys with me? Or if you try compiling your code, and the I think that C is just sticking on me. Okay. Like, is this a linker error or is this a compiler error?
Compiler.
Compiler error. It won't get to the linker stuff. Right? You guys see that? No, it's not going. So now we got a compiler error. And the thing returned 1. You guys see that? So because the compiler step didn't work, the GNU collection suite stops. It's like, nope, nope, error occurred, and it prints the error, and it stops. See that? So the GNU compiler suite goes as far as it can, and if any of those things throw out an error, it stops there.
And that's when it died at .s, right?
Huh?
It died at .s.
It died on this, yeah, so there is no .s file.
So
And there's no .i file, there's no .o file, because it erases all of these.
Oh.
So what happens when you do this, it actually will make these things, but then, yeah, it doesn't say here, but there's actually a .o file here that exists temporarily. And then it cleans up. So the compiler actually generates all these things, and then erases them if you didn't ask for it. When you give one of these things here, it just says, keep it. Yeah.
So it's like a makefile.
Yeah, makefiles, in a very limited sense, it's like a makefile.
Okay.
It knows how to build a single file.
Okay.
And the makefiles are for building multiple files together.
Yeah, like it's very similar to the file for you.
Yeah, there's multiple stages, and it cleans up and
Yeah.
stuff like that. Yeah, G++ is an amazing achievement. And the fact that it's free and open source, it's mind-blowing. Think about how many thousands or millions of years of effort have gone into making that tool. And then somebody came along and said, you know what? I can do better. So we also have Clang. Or C-Lang, as it's called sometimes. Completely different implementation. Can you imagine? Like, I know they put 5 million hours into making G++, but I've got an idea of architecting it better. I'm just gonna start from scratch and why not? And so there's actually 2 different free and open source projects that do the exact same thing. They take the exact same parameters, exact same flags, almost. Clang++, G++, exact same. Amazing. Think about it. Back in the day, you had to buy your compiler. Can you imagine that? Okay. You want to write code? All right, and $60 to board it, right? $60 in 1980 dollars. You wanna write code? And so all these open source things allow all of you. You've never paid money for a compiler, probably. Anyone? Anyone paid money for a compiler? Do you know that Intel has a compiler? You don't know? We used to pay money for Intel's compiler. Yeah, it's a truly monumental work. Okay, so we got like what 20 minutes left in class. I think that's actually good for today. We'll just take our break and then end. Anyone have any questions about this stuff? Is that interesting to you at least? Like this is like when you go into the real world, you're going to run into these things, and so knowing all those stuff is actually really important. Yeah.
So you know how like, so G++ main.cc-o, and let's just say I named it main.
Huh?
All those steps occur, but the only thing that changes is a.out's not a.out.
Yeah. If you want to change the name of the executable, -o Bob or whatever, and then this will be Bob.
But all the steps in between.
Yeah. -o changes the name of the output. If you don't give an output name, then it's a.out by default. A similar out is from the 1970s. This was just a name somebody came up with in 1970 something, and it's been the default ever since. Yeah.
How is CMake different than Make?
CMake is very different from Make. The general idea is the same. You're building a project, but CMake makes files. If you want to think about it. But like, that's a whole lecture in itself. But basically, if you've got dependencies and things like that, it'll go into a directory and say like, oh, that dependency doesn't exist, and so it'll build dependencies. It's the future. Like CMake is kind of the de facto standard now. Not the easiest thing in the world to learn that. But yeah, Makefiles will build a project in a directory. But what if you're gonna like build your project and like some dependency doesn't exist? Then you need to be able to detect that and maybe download those files and build it, put the things into the right directories. What if you're gonna be cross-platform and you're gonna have a Windows version, a Linux version, you know, or you move to a different system that's ARM instead of x86. So there used to be, oh, there still is. Something called Autocomp. It would generate Makefiles for you, things like that. It's kind of like a better version of that.
Okay.
Good question. You know, make sure that you exchange Discord IDs, email addresses with your groups, because you're going to be doing group projects. On Thursday, I'm going to be Santa Claus. We're going to be given Raspberry Pis and sensors and stuff like that. We're going to be wiring stuff and turning LEDs on. It'll be fun. Yeah.
When's our first assembly programming assignment?
Oh, yeah, sorry. So I need to figure out why you guys can't connect to the server from here. That's step 1 for me. But it's already out on the server if you can connect to it somehow. And it's not assembly.
Oh, so
Like I said, the first assignment is actually just a boring, I'm giving it to my CSCI 41 students
yeah,
right now. And like I said, it's called Zeta. And what you're going to be computing is this. That's your first assignment. You're gonna have a week to do it. That's it. So what is that?
P?
Huh?
P?
What?
Pi? It's pi n, but it's not the same pi.
That's right. So because math is math, the hardest thing about math is actually the pi character.
Darn that.
Has nothing to do with pi. This has nothing to do with 3.1415. Nothing at all in the slightest. Why did they use that symbol? I have no idea. Yeah, you know?
It's things like some sort of Greek symbol.
Yeah, but why
They love
pi?
their Greek
We all
symbols.
know what pi is. I'm like, that's 3.14
It's
times
amazing
10.
the
It's
Greek
easy,
symbol,
done.
right?
I can multiply it 3 times 5, whatever. You know? Nope. Nope, 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 nope. This is the prime counting function.
Well, welcome to the party.
And this means the number of primes less than or equal to x. So pi of 11, how many prime numbers are there less than or equal to 11?
5,
Which ones?
2, 3, 5, 7, and 11.
And 11. You guys understand? So pi, why pi? Call it the PCF or something, I don't know. Like, that's my biggest issue with math, is like, they're like, I don't want to write 3 letters. So I'm just going to use this thing that everybody knows is 3.1415 and just repurpose it. So, yeah, the pi of 11 is 5. What is the pi of 12?
Also 5.
See that? Sarah? Also. Okay. And so what you're going to do is, like, if I tell you, if I give you 11 as the starting number, I is 11, and J, the ending number is 12, your code is going to output the sum of all the pi's of x from 11 to 12, and so the output of your code is what? If you add up all these things, what do you get?
10.
10. That's it. That's your assignment. That's nothing to do with assembly. I just want to see if you guys can do it. Okay. If you guys can do it, then the 41 students can do it, right?
Yeah.
That's how it works. Do you need me to go over that again?
Not really.
That makes sense? So you're gonna have to write a function that just tells you how many prime numbers there are less than or equal to a number, and then you're gonna add them all up. So starting at some number, going to some number, add up all the numbers, that's it. Yeah.
Do you have like a really slow running time, basically? You're just
Am I?
I don't know why, I'm just asking.
So it might be really slow. I would start off by getting your code to work.
I know you mentioned it in 41.
Yeah.
Now it's gonna speak really
Sure.
slow.
Yeah. If you want to, I mean, I can run it for you if you want.
Okay, go ahead.
So like, let's run it. So if I start at 11 and go to 12, the answer is 10. You guys see that?
Okay, good.
And if I start at 11 and go to 13, what's the answer going to be?
It's gonna be 11.
Alright.
Huh?
11.
Do 11.
11.
13's in front.
60.
Oh.
You guys see that?
Bring it on there.
What if I start at 11 and go to 14?
It's gonna be 22.
Bring it up, right? 1.2.
4?